by Thursday. I haven't got them graded yet because I didn't get them until Friday and I was out of town all weekend. But you'll know by Thursday.
Do you know who everybody she got? Because when I went, they left the board. And when I was.
I've got yours. Okay, if y'all wanna log into Nearpod to follow along, I'll put it on the screen, but if you log into Nearpod, it'll be right there in front of you and easier to read. I usually use Nearpod a lot more than I do. I did this semester. And the class codes you want to join, this is not the same as the one I gave you for the student pace lesson. This is the one for the in-class lesson.
Now, Ms. Flint, will there be questions that follow along this section in your time?
It's where you have the blank spaces in your slides.
Oh, okay.
Basically, I made the guided notes for this section out of the presentation I did in Nearpod and gave you some extra pages to write in.
Is that on like 59 pages or something of slides?
Mine says 46.
I've got 59 and there's a slideshow.
Okay, no, you need to actually log into Nearpod.
Okay.
You don't have to be on the computer, you just go and dock it. Have you ever logged into Nearpod before?
Yeah, I always do give that code to give us.
Okay, there's your lesson code up there. ROSKC.
So we won't be able to print this one.
No, that's the reason I put the one in Shelby that you can print.
And that's the one.
Yeah, that's the one you
want
only do pages.
Yeah.
Yeah, for some reason, well, it's because I put in the extra pages, the extra slides, you to have room to write. You can write on the slides, but sometimes if you're copying down steps to a problem, you need more room than what's on that one slide.
So I can go ahead and print this down.
You can, or you can go into Shelby if you can take your notes in Shelby.
I don't like that.
Okay, that's fine. Yeah, you have the option even in Shelby of actually printing out that whole document, but it is 51 pages long. Normally, if I had a little more time to prepare, I would have went ahead and made the regular guided notes that are, you know, in a PDF document or a Word document, and give you those instead, because they're a little shorter. But I didn't find my copy of those, so I just made one single lesson in Shelby. The rest of the chapter, you'll have the regular kind of notes.
Okay, so like the ones that we have in Shelby, that's just for 5.1?
That's just for 5.1.
Okay.
So the plan, everybody gets their notes printed and we try to get started, because 5.1 is relatively short, even though it has 59 pages of notes, the way it's made. Today, we're going to cover section 5.1, which is simple and compound interest. It shouldn't be something you've never seen before. And then on Thursday, and I will try to send all the notes and everything out before Thursday, so you'll have them in before class. And I don't know if I'll use Nearpod or not, but I will give you regular class notes. Thursday, we'll cover section 5.2. And then next Tuesday, we will do section 5.3. And then next Thursday, we'll have the test. And this one, I normally make my exams comprehensive, but this one's gonna be just over chapter 5. Because there's enough different ideas in chapter 5, I don't wanna make the test too long by trying to include things from prior tests. So there's our game plan. And then the following week, we'll start chapter 10 and go through chapter 10. And in chapter 10, I will warn you, I'm gonna hit the parts that I know you need for calculus. There's a lot of extra stuff about loss for logarithms, things like that in chapter 10 that you don't really need to know how to do. So I'll probably streamline a lot of chapter 10 and focus in on the graphing and the things you need to know how to do just for going on to business calculus.
And did you say that you reopened up the skills, the review quiz for chapter 5? No, wait.
Oh, I do need to do that still.
The skills check quiz, yeah.
Yes, I will do that right now.
Thank you. And then.
Oh, wait, I think, yeah, I was already in there.
And then some of the duties, well, 5 ones.
I probably need to straighten them up. So let's get that done. See, today's the 28th. You should be able to get the skills check done by the 31st. If you need it, the homework will be open until the 31st. But once again, you do not have to do the homework. You only have to do the quiz. The homework is longer and it has the helps. The quiz is what I go by. But if you get into the quiz and say, oh my gosh, I don't know how to do this, then go do the homework instead.
It won't let you do it.
You have to at least open the quiz first.
Okay. I was gonna say
Once you've
that.
opened it and, put something in, anything,
But it seems like I did that and it still won't.
it should let you in.
Okay.
Because I've got it set to where you don't want to go straight to the homework and just skip the quiz, because if you know how to do it, why do 30 problems when you can get by with 10?
Yeah. Well, there was some of it, I was like, it's been a while since I've done it, so how do you do this again?
But once you've opened the skills check quiz, it should let you go to the homework instead. And then you don't do anything more than what you need to do. So let's see, we're going to cover 5.2 on the 4th, so the homework will be due on the 6th. That way we'll know it. Well, let's give you till Friday. Give you till the 7th. And then we'll cover 5.3 on the 6th, so we'll give you until the 9th to get that done. And then the review quiz will be the night before the test. And the test will be, well, by the way I'm doing it, I told you next Thursday would be the test. I think we'll probably do the test on, let me see. I think I'm getting my dates mixed up. Okay, this is today. You have until Friday to get that done. We will cover 5.2 there, so we will give you until the 3rd to get that done. And then give you until If the test is on Thursday, you've got until the 5th to get the quiz done. I think that works. Because I really need to save enough time for us to actually get through what we need to in chapter 6, because that's really important for next semester. So that should have saved all the updates.
What's the code from there?
And it's all caps, ROSKC.
Oh, it just did something that. Okay, I'm good.
You good?
Yeah.
Okay. Now, I'm actually signed in as a student myself, but I've also got my teacher account up, so, you'll see what I'm seeing and I'll see what you're seeing. So the first thing we're gonna talk about in this section is gonna be simple interest. And I think probably maybe even in elementary school, but when you first start doing some formulas and things, they start talking about interest and doing simple interest and maybe even compound interest in the early part of high school and college. In Algebra 1, they do some things like this. So simple interest, you calculate interest based upon the amount of money that you initially put in, which is called the principal. It's also in some places called present value. R is the annual interest rate, and it's reported as a decimal, and that's because in simple interest rate, it is always based upon a year at a time of interest. And then T is the amount of time in years. So that may be 1 year, it may be 3 years, it may be 5 years, but it may also be 6 months, which would be a half a year, or maybe just 1 quarter, which would be for just 3 months. So just because it's simple interest doesn't mean that you have to actually get paid for the whole entire year. If it's a savings account, you can check what you make at the end of every month. And they're not gonna compound it every month. You'll know how much you should have per month, but it won't actually post to your account. Whereas compound interest can be compounded monthly, it can be compounded quarterly, it can be compounded semi-annually, and you will actually receive those amounts at those regular intervals. So you actually gain more interest using compound interest. Simple interest, you gain the least interest. But if you take a loan at simple interest, it's actually a better deal for you, because they add the whole entire amount of the interest to the principal of your loan and then just divide by your number of payments.
Are we going to memorize the formulas? for
No,
the
you will
test?
have the formulas on test. I don't believe anybody should memorize formulas, ever. So I will give you a formula sheet. So for an example here, to buy furniture for a new apartment, Pamela Shipley borrowed $8,000 at 8%, or excuse me, $5,000 at 8% simple interest for 11 months. So she only borrowed it 11 months. She paid it back at the end of 11 months. And then how much interest is she going to have to pay? And in this case, it doesn't make any difference if she makes payments along the way or she just pays it all at the end. She still has to pay that flat amount. So this is how we would do that problem. Since 8% is the yearly interest rate, that means that's R. And that has to be converted to a decimal, and that is converted to a decimal by moving the decimal from behind the 8 2 places to the left. And that's probably part of what's in your skills check quiz, is do you remember how to change decimals? So the R is going to be 0.08 for the annual interest rate. The principal or present value, the amount that she borrowed, is $5,000. But she's not going to do the total year, so T is not going to be equal to 1. 1 year is 12 months, so for 11 months it will be 11 over 12 for the proportion of the year that she keeps it. And then, as you see there, when you do the arithmetic, she's going to pay $366.67 in interest. So it's just a simple matter of doing some really simple arithmetic. And then being able to appropriately round your answers. And in this chapter, you're gonna always round your answers at the end. Never at the beginning, you're gonna round them at the end of the calculation. And you're always gonna round to 2 decimal places because it's money. We can find what's called the future value, which is the amount at the end of the period. You can find the future value by taking the amount that you initially borrow or that you initially put in the account and add on the amount of interest. And that's what this is doing. It's saying take the part that you put in, so this is the principal, and then plus the interest that you earn or the interest that you pay, added together gives you the future value. But an easier formula for that future value is realizing that you have the principal being represented in both terms of that equation. So you factor out the P, and you can multiply the principal times 1 plus R times T. Now, it doesn't make any difference to me if you use this formula or if you calculate the simple interest and then add it back to P. It's entirely up to you. But the future value and maturity value lets you do it all in one step. So for example, find the maturity value for a loan at simple interest. And our first loan is $2,500, and it's going to be repaid in 8 months at an interest rate of 4.3%. So here again, we don't have a full year. We only have 8 months out of 12. And our interest rate, we're going to need to move the decimal 2 places to the left, and it'll be 0.043. So our time, T, is 8 divided by 12. And you can actually keep it 8 divided by 12 in your calculator if you want to. You do not have to convert that into 2/3. You can keep it 8 divided by 12 when you put it in your calculator if you wish. And the maturity value is going to be A is equal to 1 times the present value, which was the $2,500, times 1 plus the interest rate times the time. So with a present value of $2,500, and multiply that by 1 plus the interest rate of 0.043 times the amount of time, which is either 8/12 or 2/3. I'm just going to use 8/12. That will give you your future value, which turns out to be $2,571.67. And notice that that is exactly the same answer we would have gotten if we had taken $2,500 times the interest rate 0.043 times the amount of time, which was 8 out of 12 months, get the interest, and then add back the $2,500 that we had to start with.
Wait a minute, I think, oh, you did it 2 different ways?
2 different ways.
Oh, okay.
Just showing you that even though that formula doesn't look like taking P and adding it to PRT, that is what it's doing. It does come to the same conclusion. Okay? Now, this is not part of this problem, but if this really was a loan at simple interest and the loan is for 8 months, the way they would calculate the loan payments for this is they just simply divide that total amount by the 8 months. So the payments on that loan are going to be $321.46 a month. Okay? Now, that's not part of the problem that was asked, but that's actually the way they do simple interest loans. And yes, there are still places you can get a simple interest loan. You cannot usually get a simple interest loan for a mortgage on a house because they just simply don't do them that way because of the period of time being for so long and interest rates could fluctuate so much. But they do at a credit union. Most banks don't do this, but a credit union still gives simple interest loans for automobiles and personal loans. So I saved a significant amount of money just using myself as an example. When I bought my car, I didn't go to my bank where my payments were going to be higher and the amount of interest I would pay over the long run would have been more. I went to my bank and got a car loan for my car at 2% interest where the bank was charging me 3%. And they basically added 2% of the purchase price of my car to the car amount for the loan, and then just divided that into my 48 payments.
You mean the union?
A credit union.
Okay, so you didn't go to the bank, you went to the credit union.
I went to a credit union to get it. I have an account at a credit union. I use TVA Federal Workers Credit Union in Johnson City. But Eastman Credit Union also is a credit union, and they probably do simple interest loans as well. So a credit union still does simple interest loans for a lot of things. A bank always does amortized loans, where they charge you a lot of interest on your first few payments where you're paying less towards your principal, and then more of your payments go toward the principal and less toward the interest as time goes on.
A mortgage works the same way.
A mortgage works the same way, but basically when you get a car loan at a bank, it's just a shorter term mortgage. They just don't call it a mortgage because it's not for a piece of property. So the B part says find the maturity value, once again. This time the loan is for $11,280, and it's only for 85 days. So whoever borrowed this money didn't need it for very long. Maybe they were expecting a lump sum payment to come in 3 months or 2 months, and they wanted to be able just to borrow this amount of money, maybe for a down payment on something until they got that lump sum payment and could pay this loan off. So the loan is for 85 days at 7% interest. So again, the principal value, the present value, is $11,280. And we're going to multiply by the quantity 1 plus the interest rate, which is 0.07, times, now 85 days. How many days in a year?
I read that last night, 306.
Generally a bank uses 360.
That's what I thought it said 365 days, that's why I got confused, I was like, what?
Yeah, it actually is 365 days. So in this problem right here, to start with, we'll do 365 days. Then we'll go back and we'll do it with 360 days. You'll see that it really doesn't make much difference for 5 days. So really, a year is actually 365 days. Don't forget to put that fraction in parentheses. And that makes your future value $11,463.88. But it's common practice in financial institutions to use, rather than 365 days in a year, they use 360. And notice that it makes a little bit of difference. But notice that it makes a little bit of difference in their favor. Instead of the future value being $11,463.88, it's $11,466.43. So that 5 extra days being in that time period actually works to their benefit. And granted, that's not a lot of money, but still, they're working it to their benefit. And the comment here was in example 2, and I'll put the calculations back up there so you can make sure that you got them correct. In example 2, we assume 360 days in a year. Historically, just to simplify calculations, it was often assumed that each year had 12 30-month days. So it made it a year. 360 days long.
What was the, code for the
Let me move calculator.
I got it.
ROSKC.
Oh. Alright.
You're doing the student-paced lesson probably. I'm in the classroom-paced lesson. It's the same lesson, it's just that I'm controlling the pace of the lesson instead of letting you go through forward and back at your own leisure. The other code's still good.
So what is the one
ROSKC. So here we've got a simple interest rate example 3. Alicia Rinke wants to borrow $8,000 from Robin Martin. She's willing to pay back $8,180 in 6 months. So what interest rate is that she is willing to pay? And in this case, the present value is the $8,000. The future value is $8,180. The time is 6 months, or 6 over 12, or 0.5, because it's half a year. But the question is, what interest rate can she pay that will let her pay that much back?
What do you represent the future rate with, like P was 8,000, T was 0.5, the rate we're trying to find, so what do you list for your future value?
That's A.
That's
A is
A.
always the future value. So if we plug this into the formula, this is what it looks like. Your formula is A equals P times 1 plus RT. And your future value, your end amount, is $8,180. It's also called the maturity value. When the loan matures, that's the actual payout. The total of the interest plus the principal. So the future value is $8,180. Present value is $8,000. We know the period, we know that it's half a year, 6 months. We don't know the interest rate. So what we'll have to do in this case is we'll have to distribute the $8,000 through the parentheses. So we'll have 8,000 times 1 is 8,000. And then we'll have 8,000 times 0.05 is 4,000 times the interest rate. And subtract your 8,000 from both sides. And that leaves you with $180 is $4,000, or 4,000 times R. And to solve for R, you divide both sides of your equation by the 4,000. And that gives you the interest rate of 0.045. So this one's going to require a little algebra. And since your interest rate needs to be in a percentage, then you simply move the decimal. This time, going from decimal to percent, you're going to go to the right. Instead, it'll be 4.5%. Now that is the short way to do it. That is the shortest way to do it. You can actually do that problem another way, but you have to actually think through. So just to encourage you to use your formulas, I'm going to switch over here for a second. Just make a note before I do. Just so that you understand the process that formula is actually going through. First of all, in order to find the rate, you need to find the amount of interest, because that's where the rate is used. So if you find the amount of interest, interest is principal times rate times time, because it's simple interest. And you get the interest by subtracting your 8180, which is your maturity value, minus your 8,000. So principal times rate times time is actually equal to the $180. That's the amount of interest that she's willing to pay. And since you know what the principal, the present value is, and you know what the time is, what you don't know is R, the rate. But you do know that that's equal to 180 for the total amount of the interest. So then 0.05 times 8,000 is again 4,000 times the interest rate, and you still wind up dividing 180 by 4,000. So your interest rate is going to be 180 divided by 4,000, which turns out to be the 0.045. And then since we want it as a decimal, then we write it as 4.5%. So this is the process, but the formula shortens that down to the number of steps that you have to do without your having to reason it out. And again, I'm going to give you the formula. Now, if you're all logged in, I think you've been sitting there looking on the first slide this whole time, so we're trying to page us through. Somehow these are not connected. I don't know what's going on with them. They're not working right. So I guess I'll just continue going through up here. Okay. Compound amount. The compound amount, as we've just seen, for simple interest, not compound interest, but simple interest, was A equals 1, or A equals the principal, the initial amount invested or deposited, or borrowed, times 1 plus the interest rate, which was RT. So this is the amount of the interest per compounding period in this case. And it is raised to the nth power because it is possible they will compound the interest monthly, or quarterly, or semi-annually. In fact, there are some instances where interest is compounded daily. So the way that this is different, I is your interest rate, but it is your periodic interest rate. It will be good to make the note here that I is R over M because it's the periodic interest rate. It is not the annual or the stated interest rate. Okay, R is the rate for the entire year. I is the rate for each compounding period. So if they charge you 12% interest, but it's compounded monthly, then you pay 1 over 12 each time. So your monthly interest rate is going to be 1%. And then N is actually the number of compoundings. How many times are they going to compound? If they compound monthly, they're going to compound 12 times a year. If they compound semi-annually, they're going to compound twice a year. And T is still the number of years, but M is the number of times during any individual year they compound the interest.
What exactly is compounding? Like when you say it's.
When you, rather than taking your total amount that your interest plus your principal and dividing it into even payments, the way that compound interest works is for the first month, and I'll use a savings account as opposed to a loan because it makes more sense to do it that way initially. Let's say you put $500 in the bank at 12% interest compounded monthly. Okay, at the beginning of the period, you have $500. Okay? Plus, at the end of that month, you'll have $500 plus 1% $500, which is $5. So then at the beginning of your next month, you'll have $505. And then your $505 will earn you 1% interest over the next month. And 100% of $505 will be $5.50. So you take $505 plus $5.50 is $510.50. That becomes your new principal for your third month. And then in the third month, you earn 1% interest on that. So you multiply that times 1%, and then at the end of that month, that's the total amount that you have in your savings account. And then the next month, you add another 1% of whatever was in at the beginning of the month, and you have that much more. So what happens is, your interest on the first month is less than your interest on the second month. And that's then the interest the next month goes up again, because you're earning interest not only on what you initially deposited, but you're earning interest on the interest that's already been paid. So that's why your money grows faster, or it's also why your loan value becomes higher. The amount you have to pay back will also grow faster. So here's an example. Let's suppose that $1,000 is deposited for 6 years in an account that pays 4.25% per year, compounded annually. So they're still gonna compound once a month here. I'm sorry, once a year, but it's gonna be for multiple years. So without going through the compound interest formula first, so that you understand how this actually works, let me take a little sidewalk here. So we have $1,000 as our present value. And time is going to be 6 years. The interest rate is 0.0425 annual interest rate. And it's going to be compounded annually.
You know, if those compounds in that annually, would then equal 1/2?
No, I'll change the wording for you, and we'll look at how that works out differently. So this is exactly what the problem says right now. So here's what happened. Day one. In your account, you have $1,000. Okay? At the end of year one, what you have is your $1,000 plus 0.045 times, I'm sorry, 0.25 times $1,000. So at the end of the first year, you have $1,042.50. This is just going to be one of those days. So now, day one, year two, that's how much you got. And then at the end of year two, you're going to get that amount plus 0.0425 times that amount. And to shorten the calculation, the things that I'm gonna have to enter, I'm using the answer on the calculator. So I'm taking the answer, which was that amount, plus 0.0425 times second negative sign gives me that same answer. So answer in both those cases is $1,042.50. So at the end of your second year, what you actually have is $1,086.81. And then that becomes your day one of year 3.
So you do that 6 times for the whole 6
And you have to keep doing that 6 times. Now, you can see that this is going to be a very tedious process. But you can also see that your money isn't growing by $42.50 every year. In some years, it's growing by more than $42.50. Everything past the first year, you're getting more than $42.50 in interest for that. So I will do that one more time. I can automate it on here. So at the end of year 3, at that time I have $1,132. And actually it'd be $11.33 because that's 99 cents plus. So we'll call that $11.33. And then if I do it for one more year, because that becomes my year 4 beginning. I'll have $1,181.15. So let's see, we've gone, this is year 4, we need 2 more years. So at the end of 6 years, I'll have $12,083.68. So this is compound. Okay? That's what I have at the end of 6 years. At the end of each year, you get a little more in interest than you did the previous year. That's kind of.
How would you do one that's compounded continuously?
There's a special formula for that.
Oh,
Okay? Now, do I really want to go through all this math every time I have to figure out compound interest? The answer is no. So we're going to actually do the formula. But before we do the formula, I want you to compare this to simple interest. Because if this had been simple interest, our future value would have been our initial deposit, which is $1,000, times 1 plus the annual interest rate, which is 0.0425, times the 6 years. And I only have $1,255. So compare those two amounts. Simple interest, you don't gain near as much.
And that's because simple interest is taken in the whole amount as a whole.
Right.
Okay, and they don't take into consideration if you had any, if you added to that account.
No.
with your
No, this is assuming you never make any deposits. Okay, and both of them are assuming the same thing, you never make any
Yeah.
deposits.
But in simple interest, you're not adding the interest into.
Yeah, you're not getting paid interest on your interest from the
Yeah.
previous years. Whereas with compound interest, you're actually earning interest on both the principal you initially deposited, plus the amount of interest that you've already earned. You're earning interest on your interest. So that's why you have, quite a bit more, about 3368 more, okay? And that's only on $1,000. Of course, if the interest rate had been higher, then that would be one thing, and if the compounding periods had been longer. What happens is that compound interest far outstrips simple interest. The longer you leave it in there, the further apart they're gonna get, the more you're actually going to gain. Wrong one. Now, the easier way to do it than the way you just saw me take up a whole sheet of paper doing arithmetic is we use the compound interest formula. And in the compound interest formula, it is the future value is equal to the present value times 1 plus the periodic interest rate, which is I. And the periodic interest rate is the annual or the stated interest rate divided by how many times you compound. Okay, and that depends on what the compounding period is. If it's 6 years and you compound yearly, then it's going to be the interest rate divided by 6. If it had been compounded semi-annually, it would be the interest rate divided by 12. If it was compounded monthly, it's the interest rate divided by, I think I said that one, 12. If it was compounded quarterly, you divide by 4. And then your actual evaluation of N is not just the time in years, but it's how many times did you compound. So in 6 years, we compounded 6 times. If we had compounded semi-annually, we would have compounded 12 times. Or if we had compounded monthly for 6 years, we would have compounded 72 times. So that's what N actually represents here. But that was a lot shorter calculation right there than what I went through on the page trying to explain to you what's going on. So I want you to understand why things work the way they do, but I don't want you necessarily to have to do a whole page of arithmetic just to do one problem. That's why we have our finance formulas.
So I'm having trouble understanding what the difference is between, I know you explained it, but I didn't hear it again, between I and R. Interest rate per period and interest rate.
R is the annual interest rate. It's usually the interest rate they quote you up front.
So,
You know, you're gonna pay 2% interest on your car, you're gonna pay
APR.
APR, annual percentage rate,
Okay,
okay? But your APR is always divided by how many times you compound during the year. So your APR maybe for your mortgage might be, probably right now it would be a bit hard to get a mortgage for 6%. So your APR would be 6%, but then your monthly, your periodic interest rate will be 6% divided by 12.
So do you want us to remember the APR, MT, and I, and what they stand for?
I'm gonna give you those on a formula sheet. Just be sure that as you're working your problems, you remember those. Okay? Have that formula sheet in front of you if you need to, because you're gonna have it on test.
so in my mind, annual interest rate is more of a simple interest, but the interest rate per period is the compounding.
Compounding interest rate.
Okay.
Now, the next part of that last question, find the amount of interest that was actually earned. Well, we've already seen that the total amount earned was $1,283.68. What we initially put in the bank was $1,000. So the amount of interest earned, this thing's going too fast for some reason. The amount of interest earned is the maturity value minus the initial value, or the future value minus the present value. and that's $1,283.68 minus 1,000. So the amount of interest that was earned on that account was $283.68. That's always the way you find the amount of interest. Future value minus present value. What you have at the end minus what you had at the beginning. Okay? So our next one, again, it's compound interest, but we're not gonna do the big drawn out calculations, we're just gonna use the formula. Says we wanna find the amount of interest earned by a deposit of $2,450 for 6.5 years at 5.25% compounded quarterly. So your APR, your annual interest rate, is 5.25%. But what is I going to be?
0.0525.
Okay, how often do we compound? What does it say?
Quarterly.
So what do we do to that interest rate to get I? Because remember, I is not the stated interest rate.
0.0525 times.
Is it times 4? That means you're gonna get 4 times as much interest.
It's divided.
It has to be divided. Quarterly means every 4 months. A quarter is, I'm sorry, every 3 months. So it is 1/4 of a year,
Yeah, I was looking at.
okay? So you're either gonna multiply it by 1/4 or divide it by 4. Okay? And then your 6.5 years compounded 4 times a year. So that means you're gonna compound, whatever 6.5 times 4 is, you said 26, okay?
So P is 24.
Yes,
I is
0.0525 divided by 4, and then N is the 6.5 years times 4, which makes N be 26.
6.5 years times.
Now, do you know where that 4 is coming from?
The quarterly, I'm sure.
Right. There are 4 quarters in a year. So you get 1/4 of your interest in each quarter, but you also compound 4 times per year. So if it's 6.5 years, 4 times 6.5 is the number of times that they're actually gonna compound your interest. Okay?
That's what I'm having trouble with that one. So.
Well, and you've got this to go back to help you remember those things. Because it explains up here at the top, it says the interest is compounded quarterly, so the number of compounding periods per year is 4. And in 6.5 years, there will be N is equal to M times T.
Oh, you'll do it 4 times per year.
Per year.
Times 6.5.
Right, for the
Okay.
number of years, okay?
Yes.
And your interest rate per quarter is the stated interest rate divided by the compounding periods, and that's 4, so it's 0.0525 divided by 4,
Okay.
okay? Did you have a question?
Yeah, it was, when you get to it, can you show how to do that on a calculator when you,
Yes, that's the reason I brought this, and I like doing Nearpod because it makes it easier to pop the calculator up and still have the presentation right there and not cover anything up. So the way that this is gonna go in is you start out with your principal, your present value, $24.50, and then you know you've got parentheses, and then 1 plus, and that 1 basically just says you're gonna start out with this much money. And then the other part figures the interest rate for you. So the interest rate is 0.0525 divided by 4 for compounding quarterly. You don't need parentheses around that 0.0525 divided by 4 because the only other operation is addition, and order of operations says you divide or multiply first, and then you do your addition at the end. So that gives you the right order of operations. And then we need to raise it to the power. And if you don't want to sit there and separately multiply and say 4 times 6.5, you can actually do it in the power.
So what did you press to do
That power key,
that? Yes.
right here. See it?
That little carrot.
The little caret, it's right below the clear button.
I was trying to figure this out.
And you are recording this, right?
Yes, it's being recorded.
Okay.
And then we're gonna multiply the quarterly, which is 4 times a year, times the number of years, 6.5. And you put that in parentheses because you want the power to be that multiplication problem, not just the first number it sees.
Okay.
Okay, so that needs to be in parentheses if you're not gonna find all this out up front and plug in the resulting values. So you can plug it all in to begin with, but you have to be careful and use all those parentheses. Okay? And then you hit enter.
So would there ever be something besides like quarterly that we would divide by that said something else?
Semi-annually, you would divide by 2, because it's twice a year. Monthly, you would divide by 12, because it's 12 months and 12 times compounded. It's not likely you'll have daily, but daily it would be 360. Okay?
Every year, we use 360 too.
Yes, for financial formulas, we're just gonna, take the convention of using 360 unless you're told specifically to do otherwise.
Why did he do that? 360 rather than 365?
Because it just makes the calculations easier. I mean, that's the stated reason, it makes the calculations easier. The truth of the matter is, using 360 does make it easier. It also means they get more interest.
Understood.
It's not that much, but it still comes out to their advantage. They don't lose anything. Okay? And I'm gonna talk to you more about this next time. We're actually gonna practice with this next time, but I don't wanna get into it today. Your graphing calculator has a routine set up in it that it will compound, it will do compound interest for you as long as you know how to put the numbers in the calculator. So we are gonna do that. I want you, for simple and compound interest, to know how to use the formula, because you don't always have this handy, and you can do the compound interest formula if you have to. You can use it with just a little handheld calculator. You're not always gonna have the graphing calculator with you, but I am gonna come back to this. This does explain how to use it, and we will actually walk through that. So, as I've already told you, it's interesting to compare loans at the same rate when simple or compound interest is used. And the figure I'm going to show you shows the graph of simple and compound interest formulas, starting with a principal of $1,000 and an annual interest rate of 10% for 0 to 20 years. And look at what happens to the future value. So if you look, you start out on day 1 with $1,000. And for the first couple years, there's not a lot of difference between your future value. But by the time you get out here to, let's say 10 years, notice that the difference is pretty close to $1,000 difference in the future value. And by the time you go out to 15 years, if you had simple interest, you'll have $25,000, but if you have compound interest at 15 years, and it's being compounded, I think that's compounded annually, then instead of having $2,500, you're gonna have $4,177.25. Now that's a substantial difference in the amount of money that you're gonna have in that account. And if you carried it on out to 20 years, you can see that it would be even larger than that. So it isn't that simple interest doesn't keep gaining in the balance, it's just that compound interest gains much, much faster. And that's why the business world uses compound interest much more than simple interest. So in this one, we say, suppose Susan Nassy invested $5,000 in a savings account that paid quarterly interest. Quarter means 4. After 6 years, the money had accumulated to $6,539.96. What was her interest rate? Now, I don't actually like problems like that, to be honest with you, because if she put money in the bank, she should know what the balloon interest rate was when she put it in the bank. This is kind of dumb, but.
So P is 5,000
Uh-huh.
and K is 6539.96.
Mm-hmm. And then it's 1 plus the rate divided by 4, because it's quarterly, and it's 6 years. Quarterly is 24 for the number of compoundings. So we have 5,000 plus R over 4 raised to the 24th power equals the future value. We subtract, we divide both sides by the $5,000 to get the $5,000 off of the left side and into the right side. So all we have left is the parentheses. And then once all you've got left is the parentheses, you take this power and take its reciprocal and multiply by the reciprocal of that power on both sides. In other words, you flip that power upside down. Instead of being 24, it's 1 over 24. Because if you take the 1 over 24th power of this and the 1 over 24th power of this, that 24 disappears into 1. But you have to keep this one. And then you subtract the 1 for both sides. So 1 subtracted from that leaves this. And then you'll multiply both sides times 4. And the interest rate was 0.045. I can promise you I won't ask you something like that on test, but I'm not gonna tell you you won't run into one in my math lab. That goes in my box of what I call stupid problems. It's the same kind of problems, that you had back when you were doing algebra word problems, and it said Mary is half as old as David on their 4th birthday, and by the time they're both 28, she's twice as old as David. It was like, who cares? Do they know how old they are? I don't want to work a puzzle to figure out how old they are. And I don't like the ones either that says, Sam has $4.38 in his pocket. He has twice as many nickels and dimes and half as many quarters as he has pennies. How many of each coin does he have? Take the money out of your pocket and count it. That's dumb. You don't waste algebra time on that. So, I want to know what you're going to pay in interest. I want to know what you're going to have in the future. I might want to know how much you need to deposit today to have a certain amount in the future. But I'm not going to make you figure out the interest rate. If you borrow money without knowing the interest rate, you're dumb. And most people that dumb don't have any money, so. Now, we also have something called effective rate. Effective rate, here's just the example to kind of get you the idea of what it is. Suppose you deposit $1 at 6% interest compounded semi-annually. That means that 6% semi-annually is 6% divided by 2, because it's twice a year. That would be 3% every 6 months. And you're going to compound it for 2 periods. So in other words, for a year. Okay? At the end of the first year, the compound amount turns out to be 1.06090. That means your dollar increased by 6.09%, or by 6.09 cents, which is an annual increase of 6.09%. And yet if you look at the stated interest rate, that was only 6%. It's because they compounded semi-annually that it actually felt like you were getting a higher interest rate. And that's called the effective rate. The effective rate is different from the stated interest rate, and it's higher, much higher, depending on how many times in the period that you actually compound.
So it's the effect of
Having extra
on your
interest, yes, that's exactly what it
Okay.
is. It's the effect of getting interest on your interest, and the effective rate becomes higher if you compound more often, which ought to make sense to you because, you know, you have more periods that you're compounding on. Sometimes it is good to know the effective rate. So Joe Viteri needs to borrow money. His neighborhood bank charges 8% interest compounded semi-annually, but there's an internet bank that charges 7.9% compounded monthly. Which bank is Joe going to choose to do his loan? Anybody want to take any votes looking just at what we know right now? Which one would you do?
You would think that the 7.9 would be higher than.
Yeah, because the interest rate's low, right?
Yeah.
Okay. It isn't a lot lower, but it's still lower, so he probably, if he doesn't think, he's gonna go straight to the internet bank because they have a lower interest rate. Now, let's look at what happens.
It depends on the period of time
That's right. The period of time of compounding has a lot more influence than that 1/10% interest. So in the neighborhood bank, his effective rate is 1 plus the 0.08 interest rate, and they only compound twice a year. So the exponent on that's gonna be 2, and he's only gonna pay 8.16% effective rate. But the internet bank compounds monthly. They compound 12 times a year, not twice a year. So when you divide their rate by 12, which, you know, hey, that sounds good. But then you also have to raise that power to 12. And it's that power that actually has the bigger effect. So their interest rate is actually 8.19%. So he should have stuck with his hometown bank. Especially if he's going to borrow a large amount of money, because that interest rate does mount up depending on what you borrow. Okay?
So is that an N that's in parentheses, is 1 plus R over M, and then is that an N, where that 2 is that your N?
That's M, which is N times T. Number of compoundings times the number of years. See, the thing is, in this one, he only borrowed it for 1 year. That's why it didn't change. Yes.
Where is CLA
It's in the building behind us on the bottom floor. Not that one, that's the faculty building, the other one across the bridge. Okay?
Thank you.
You're welcome. You can also figure out what your present value is needed to have some future value. But actually it's 1021, so I'm gonna make a note that we need to start here. So start at present value. And I will see y'all next time. check homework. That homework's just there in case you need it.
Oh, yeah, the skills check. That's,
Homework, yeah, that counts.
no, homework, I need to do that. But,
The regular in-class homework for the sections, but not the skills check.
that's what it says, section 5.1.
Yeah, you do need to do that. You need to do those.
Here, I have a question.
Oh, Miss,
You're right there, Eddie. You have to do this.
You don't-
That is optional.
What about this, the chapter?
The chapter review quizzes are also required. No, it's the skills check quizzes, and all the quizzes are required. These homeworks are not required. Those are, yes, but not the skills review.
oh, so these, the skills check and this, are they review quiz?
Cause in the beginning, I know.
The skills check quiz is due before you can start the homework. The review quiz has to be done by the night before the test,
Oh, so,
because that's your study guide for the test if I don't give you anything else.
gotcha, so you want us to do those?
Yeah, you need to do the homework and the quizzes. The homeworks you don't have to do are the ones that says skills review.
Oh, so I thought we didn't have to do the review quiz.
Yeah, that's.
No, you do have to do the review quiz. If you've missed
Well,
review
I haven't
quizzes,
done
you're,
that.
well, if you've missed them, what I will do, probably the last couple of weeks of class, I'll reopen all those, because those quizzes are the best study guides you have for your final exam.
Gotcha.
And the reason I guess, the reason I misunderstood, in the beginning, you mentioned, something we didn't have to do.
Yeah.
If we did the homework.
Yeah, that's-
Because I thought,
I was
if we did that
confused by
one, we
that.
didn't have to quiz, but we just didn't have to do it. I don't know. I was looking.
Yeah, but that's only skills check.
Okay.
That's only applies to the skills
I
check.
guess I just misunderstood.
Okay.
But the
You'll have a chance to
And I
fix
don't,
it.
I don't want to really screw up my grade.
No, you'll have a chance for it to be able to fix
So
it.
what if I got like a 90 something on my quiz and then I finish the homework and then I
I'll give you the 100 on your quiz, but you don't need to do, you're talking about skills check?
Yeah.
You don't have to do the skills check homework at all.
Well, some
You
of them
only
are
have to
already,
do the quiz.
Like the.
some of them are already done, like by the time you get
Yeah,
the skills
your,
check.
yeah,
quiz.
quiz, yeah.
Yeah,
Does it like check to see what questions you got right on the skills check and then answer the rest for you or something?
no.
So, why is it like that?
The reason it's like that is because the skills check quiz are the bare basics concepts that you need to remember how to do before you can do the actual homework in this chapter. In other words, if we're going to, solve a quadratic equation for whatever we're working on in that chapter, then you'll have a skills check quiz that makes sure that you remember order of operations and how to do exponents and how to pick out numbers out of the formula. The homework is the same as the skills check quiz, except on the quiz, if you're stuck, you have to go digging around trying to find help with it. The homework is the same questions that are in the quiz, but there's more of them, so you can practice if you're rusty. And if you're stuck on one particular problem, you can go into the homework and find those problems, and it has to help me solve this, show me an example, and all those things. If you use it, that's good. If you don't use it, that's fine. You may not need to. You've got to do the skills check quiz, but the homework is only there to help you. And on the day of the test, I go in and I actually omit the grade from the skills check homework. Because some people will have a 0, they didn't need it. Some people will have a 50 because they needed a little of it, but they didn't need the whole thing. And then some people never could pass the quiz, they tried, so they just go do the homework and got the rating on the homework, and then
Oh, you switch between one
I'll
of those?
switch them out.
So there, gotcha.
But I want you to do the
Yeah.
skills check if you can, because it's shorter, it takes up less of your time. But they're really, both of them are there to help you, but the homework doesn't count.
So, what does,
The skills check,
Homework.
homework,
But you would take it in place of.
I will take it in place of the quiz, because if you are really so rusty that you can't pass that quiz in your first try or two, you're better off just doing the homework, because that way you can get help with it.
What is this? They doing it something?
Business Scout is not offering this summer, they're offering this class for the first time in 20 years, they're offering this class at the same time.
Yeah, I gotta take mine in 1 and 2, and,
See you later. did you stop giving out the sign-in sheets?
I got sent it around today, I made a note, but I'll do it next time. Make sure that it's offered, and make sure that it's offered here, not ROVP. Don't wanna do that because it's a different book. So you don't wind up buying two books for the same course that will not necessarily even be compatible. You don't wanna do accounting ones or anything else.
No, that's the problem, because really, that's the thing, if I could take it, well, that's all that's shown right now, just already account.
That's all there is. I don't think any of our accounting teachers teach.
And that's the thing, if I could actually do that, you know. This whole thing
If you're
is.
gonna, it's your choice.
Yeah,
If you take RODP accounting in the summer, take RODP accounting in the fall.
okay,
That way the transition will be better.
yeah,
But if you do that, be forewarned, number one, it's gonna cost you more per credit hour.
yeah,
And number two,
that's all.
it's all online. You will take your tests in our testing center, but you will never see your teacher.
I know, that's the thing, it's just that micro, even I'm taking like microeconomics on that, I'm struggling with it, and I'm like, I wish I could take that, and I gotta take micro. So I was like, I'm gonna do that one in the class next time, so, and I'm even glad I take this class, I've done a lot of my classes online, so I'm glad I took this one.
Well, and I have had students that, because in the summertime, up until this summer, the only Math 1630 they could take was RODP. And I would beg them, please, please, please don't take that course, take something else in the summer, and we'll figure something out. Because
See,
that
that's the
course-
only thing, because I cannot take the counting one and two at the same time.
You
And
can't.
that's the problem, you know, it's just like.
But if you're gonna do it, do both of them RODP, so at least the transition will be smooth.
Yeah. I'm afraid if I try to do it all online, I'll be struggling though.
Well, and I don't know, it just kind of depends.
Yeah. I mean, I don't know, let me ask you, if I was having problems in this, I couldn't really, could I come talk to you about that about it?
If you're having problems with the class, if it's an accounting class, I am going to be of no help. One of the accounting teachers will, if they're here, see, that's the question, I think most of our accounting teachers don't come in the summertime.
Yeah,
So, you might see if they have a tutor in the learning center, you might talk to the accounting teachers now and say, are either one of y'all gonna be around in the summertime? But, you know, I mean, accounting, I'm like, I can do better with econ than I can accounting.
yeah. It's just, did you get any of the tests?
I did not get any of them graded. I
I
had,
didn't know if you got mine graded since I turned it into you, that.
no, they're all in an envelope separated out by class.
Okay.
But, the reason I didn't get them decorated, didn't get them graded was because, I didn't get them until Friday afternoon because I was out sick Wednesday and Thursday with bronchitis.
Yeah.
And then Friday afternoon, I was away for the rest of the weekend till Sunday evening with, a conference in Knoxville.
Well, I didn't know if you had got mine graded, just because I.
No. I had hoped to go ahead and get those done, but it just didn't happen that way, because I had never had bronchitis so bad that I literally could not think.
Yeah.
I mean, it was just like,
And you know, it's been awful this year. It's like, you know, I actually had bronchitis in December, and I had it again. And I'm still like cough here and there, like trying to get rid of it. My little boy has had those strains of flu, just had strep not that long ago, several sinus infections,